Hi, today we're going to continue our talk on titanium based ceramics. Uh, so the picture here on the screen shows that it's a titanium hip replacement implants made out of titanium or chromium cobalt alloys. So a recent survey showed that the demand for hip replacement by 2025 is going to get double. I don't know the exact number, but it's going to get double. So it shows that where there is a the 3D printing and materials plays a big role in the hip replacements. So chromium cobalt alloy is the most commonly used material for making for fabricating these implants. But there's a study showing that when this chromium cobalt alloy has been implanted in the body, uh, when the soft tissue reacts with the metal debris, there is going to be heavy levels of chromium cobalt ions in the bloodstream, which are known to be toxic. So, based on these ideas, our author synthesized titanium boron or titanium nitride reinforced titanium alloys. Uh, yeah, so, in this paper, the paper title is In situ synthesized titanium boron, titanium nitride reinforced titanium alloy composite coatings, and the properties they have studied here are microstructure, tribological, and in vitro biocompatibility. The scope of this study is to study the potential for the lens laser engineered net shaping process on with the titanium alloy powders pre-coated with this barium nitride coatings toward articulating surfaces for load bearing implants. So here titanium is known for is a good load bearing material, but it has very poor wear characteristics. So by adding this barium nitride, boron nitride, boron nitride, we are going to get good wear resistant properties as well as good load bearing capacities, which is required for our application. So the key question here they have addressed is influence of processing parameters on the microstructures and how this variation in microstructures are correlated with the mechanical properties and in vitro tribological properties. So as I said, the materials used in this study are titanium alloy powder with particle size distribution varying from 50 to 150 micrometers, and the fine flaked boron nitride powders particle distribution varying from zero point 0.5 to 2 micrometers. The SEM picture on the screen shows the spherical titanium powder surrounded by bright, tiny flakes of barium boron nitride. The processing conditions employed here are they have changed laser powers from they have used two laser power settings, 400 watts and 300 watts, and they used two scan speed settings, that is 10 millimeter per second and 20 millimeter per second. And the characterization tools adopted here are nano indenter, X-ray diffraction, SEM for microstructure analysis, and linear reciprocating ball on disk tribometer for calculating tribological properties. So the key result or the key question over here is how the influence of processing parameters on the microstructures. So they did plot a XRD analysis. The bottom of the XRD analysis shows you the XRD of the powder, starting powder. It clearly shows the presence of both titanium and boron nitride powder, but after following the laser treatment, the boron powder, this O is not seen in at all conditions. And after following heat treatment for the 5-8 percentage boron nitride and 15-8% boron nitride in the powder, you can see a presence of titanium nitrides and titanium boron. So XRD analysis of laser processed coatings showed major peaks corresponding to the titanium nitride and titanium boron in all coatings, and unreacted boron nitride was not observed in any of the laser processed coating. So when it comes to microstructures with 5-8% boron nitride in the titanium Ti6Al Al4V powder, you can see fine eutectic titanium boron nanorods and titanium nitride presence in them, but at low laser processing conditions they were finer when compared to high laser processing condition. But when you increase the boron nitride percentage of boron nitride, you can see very coarser when compared to 5% weight percent boron nitride when compared to 15 weight percent boron nitride. So it says that increasing the boron nitride concentration in the composite coatings increases the formation of coarser reaction products. So we have seen finer flakes of titanium boride and titanium nitride reaction products in the microstructures at low energy densities, and with increase in laser power and scanning speed, we are seeing the coarser products. How this affect the mechanical and in vitro tribological properties? So for mechanical, you can see the Young's modulus, which is calculated using a nano indenter. The Young's modulus have been improved by the formation of more titanium boron and titanium nitride phases, which are in at high laser conditions and high boron nitride condition. That is, you can see it's 204 for 15 weight percent boron nitride when compared to 5 8% boron nitride. And at all high energy high laser settings, that is 400 watts and 10 per second, you have received the high Young's modulus. So what about the in vitro tribological properties? So the wear rate for 76 energy densities, that is 102 energy density, that is 400 laser power and 10 per second scan speed. The wear rate was very efficient, very comparable when compared to other. And they did compare with the chromium cobalt alloys, and it says that they are very good when compared to the wear resistance is very good when compared to the chromium cobalt alloys. So, and the wear resistance is directly proportional to the top surface hardness, and it can be seen there is not much influence of processing conditions on the top surface hardness, but with increasing in the boron nitride percentage, you can see a huge difference. For example, for the 5 8% boron nitride at 400 watt and 10 per second scanning speed, the top hardness is 604 when compared to the 15 weight percent boron nitride, it is around 877. So the key conclusions of the paper are they deposited the boron nitride to form novel microstructures with homogeneously distributed titanium boride and titanium nitride reaction products, which indirectly affected the tribological properties, increase their stiffness and wear resistance, and this excellent properties when compared to the generally used chromium cobalt alloys shows their potential to be used as a load bearing implants. And my personal critique for the paper or personal usefulness of the paper is it's very clear and it's very useful for the work for implant applications, and it would be interesting to see their future studies on in vivo response of these materials, as we seen that metal debris are going to cause are known as carcinogenic agents, and which are going to be toxic in nature.